Okay, so this is the final lesson in Unit 2. It is called Graphing Transformations of Functions. So what we're going to do is we're going to be taking our parent functions from the last lesson and transforming them around. So we're going to start with the vertical and horizontal translations. Okay? If your graph or your function looks like this, and you have f of x, and at the end you have plus c, that means you're going to shift f of x up c units. Okay? If you have f of x minus c, that means you're going to shift f of x down c units. And I'll explain this more when we get to the examples. Okay? If you have f of x plus c, like that in the parentheses, you may think that plus c means shift to the right, but it actually means shift to the left c units. And if you have f and in parentheses like x minus c, you may think that means shift to the left, but no, it means shift to the right c units. And again, I'll explain those more when we get to the examples. Okay? So let's try an example right now. Let's graph f of x equals x cubed plus c. Okay? So hopefully you remember about what the basic shape for x cubed looks like from the cubic parent function from the previous lesson. So this is going to be the parent function shifted up 2 units. Okay, so there's 2 ways you could do this. You could either graph the parent function, take each point and shift it up 2, or make a table. So I'm going to make a table for this one. But it's just going to be the parent function shifted up 2 units. So for the x's, I'll do -2. I'll do -1. I'll do 0. I'll do 1. I'll do 2. When x is -2, -2 cubed means -2 times -2 times -2. So that's -8 plus 2 gives me -6. When x is -1, I have -1 times -1 times -1, which equals -1, plus 2 equals 1. When x is 0, I have 0 times 0 times 0, which is 0, plus 2 equals 2. When x is 1, I have 1 times 1 times 1, which equals 1, plus 2 equals 3. And when x is 2, I have 2 times 2 times 2, which is 8, plus 2 equals 10. Now I'm going to graph this. So -2, -6, -1, 1, 0, 2, 1, 3, and then 2, 10. So this is what the graph looks like. Again, hopefully you remember what the cubic parent function looks like. This is the cubic parent function from last class, shifted up 2 units. Every point was shifted up 2. That's what that plus 2 at the end means. Okay. So let's try example 2. Graph f of x equals 3 to the x power minus 5. So this is going to be the exponential parent function shifted 5 units down. So you can either graph f of x equals 3 of x, take each point and shift it down 5, or just make a table. And I will make a table for this one. Okay, so again, this minus 5 means shift down 5. So in my table, I'll go with -3. I'll do -2. I'll do -1. I'll do 0. I'll do 1. I'll do 2. And that's all I'm going to fit. So I'll do those. Okay. Let's start with the easy ones. Let's do x is 1. That's an easy one. Okay. When x is 1, we have 3 to the first power, right? 3 to the x, 3 to the first power is 3, minus 5 is negative 2. When x is 2, we have 3 to the second power, so 3 squared is 9. 9 minus 5 is 4. When x is 0, we have 3 to the 0 power. Anything to the 0 power is 1. So 3 to the 0 power is 1. 1 minus 5 equals negative 4. And now when I have 3 to the negative 1 power, okay, these are going to be decimals. But if you type 3 to the negative 1 power in your calculator, you can get a decimal. And then when you subtract 5 from that, you're going to get approximately negative 4.6667. If you want to do 3 to the negative 2 power in your calculator, you're going to get a decimal 0.111111. Repeating, minus 5 gives you negative 4.8889. I think you see the pattern right now. But 3 to the negative 3 power in your calculator, and then minus 5 gives you about negative 4.96296, so I'll do 0.30. And now I'm going to graph this. So 0, negative 4, 1, negative 2, we have 2, 4, and estimate these. Negative 1, negative 4.67, negative 2, negative 4.89. That's my next one. So draw your graph. Think back to last class. Remember last class when we did the last example, how it approached 0 but never actually touched 0? Well, this one shifted down 5. So this graph is going to approach negative 5 but never actually touch negative 5. So that's my graph. Okay, let's do example 3. Graph f of x equals the absolute value of x plus 2. We'll make a table. So ahead of time, let's picture what the graph should look like, okay? The graph should be the absolute value graph shifted. This plus 2 means you're shifting left 2. So we're going to shift left 2. So for my table, I'll go negative 4 for x. I'll do negative 3. I'll do negative 2. I'll do negative 1, 0. I'll do 1, and I'll do 2, and I'll stop there. So those will be the x values I'm going to use for my table. So again, this is going to be the absolute value parent function. This plus 2 means you're going to shift it left 2. Left 2. Okay, so you can either graph the parent function and shift everything left 2, or you can make a table like me. I'll stick with this. I'll do 0 first, because let's do the positives first. When x is 0, 0 plus 2 is 2. The absolute value of 2 is 2. When x is 1, 1 plus 2 is 3. The absolute value of 3 is 3. When x is 2, 2 plus 2 is 4. The absolute value of 4 is 4. When x is negative 1, negative 1 plus 2 is 1. The absolute value of 1 is 1. When x is negative 2, negative 2 plus 2 is 0. The absolute value of 0 is 0. When x is negative 3 plus 2 equals negative 1, and the absolute value of negative 1 is positive 1. When x is negative 4 plus 2 is negative 2, and the absolute value of negative 2 is 2. So let's graph these. 0, 2, 1, 3, 2, 4, negative 1, 1, negative 2, 0, negative 3, 1, negative 4, 2. So again, think back to what I said in the beginning of this problem. This should be the parent function shifted left 2. That plus 2 means shift left 2. So you can see I shifted it left 2. Okay, next page. Write the function of the graph below. Okay. So think back to the parent functions from last class. And this looks like the quadratic parent function. And it shifted down 4 units. I'm going to say shifted 4 units down. Because if you think back to the parent function, it was at 0, 0, the vertex, and it went up last class. So I'm shifting it down 4. So to write that, I'm going to write it like this. I'm going to say f of x equals x squared minus 4. This number at the end tells you up or down. So down 4. Write the function of this graph. Well, this looks like the cubic parent function. Okay, think back to last class. This looks like the cubic parent function. And it shifted 5 units left. So the way I'm going to write that is I'm going to write it like this. You would think going to the left means you're going to do minus, but it's actually plus. So I'm going to say plus 5, and that's going to be cubed. Okay? If it's left or right, usually that comes in here. Think back to the first page of notes. Look back at that if you're not clear on that. But that's my answer. Okay, let's do one more like that. Example 6. Right there. Your graph doesn't have these arrows. Same thing for the last problem. Draw them in. Okay. This is going to be the absolute value parent function. Think back to last class. This is the absolute value parent function. And it shifted 1 unit right and 2 units down. Okay. Shifted 1 unit right and 2 units down. So here's how I'm going to write that. I'm going to say f of x equals. It's going 1 unit to the right, so you may think that means plus, but it actually means minus 1, like that. Okay, inside usually tells you left or right, and out here I'm going to put minus 2 to indicate that I'm going down 2. Okay, so if you see, so this next thing talks about reflections. Okay, if you have, let's see, to reflect across the x-axis, I'll start with that one. You multiply by -1 to get negative f of x. So if I say graph something like this in number 7, that's going to be reflected across the x-axis. Okay, if you want to reflect across the y-axis, you multiply every x by -1. So let's see. I mean, I can read through that more, but let's just try an example and see what that means again. Okay. So this one right here, graph f of x equals negative square root of x. This is going to be the parent function, the square root of x, parent function from last class, shifted or reflected across the x-axis. Okay, this is going to be the parent function reflected across the x-axis. So let's make a table to see that more. That negative out front means you're going to reflect it across the x-axis. Okay, so let's do 0 for x. Negative square root of 0 means negative 0 or 0. Let's do 1 next for x. Okay, the square root of x. The square root of 1 is 1 times negative equals negative 1. Let's do 4 for x. The square root of x. The square root of 4 is 2 times negative equals negative 2. And let's do 9. The square root of x, the square root of 9 is 3 times negative equals negative 3. So we're going to graph this. So we got 0, 0. We got 1, negative 1. We got 4, negative 2. And then we have 9, negative 3. Let me draw the graph. Again, think back to last class, but this is the square root parent function just reflected across the x-axis. Last time it went like this. But we're reflecting that across the x-axis because of that negative sign out front. Okay. This next page talks about stretches and shrinks. So you can read through that on your own if you'd like. And again, you have my lesson packet on Classroom or Canvas, depending on when you're watching this. Okay. But basically, if the number out front is greater than 1, greater than the absolute value of 1, meaning if it's 2, 3, 4, 5, negative 2, negative 3, negative 4, negative 5, that's going to be called a vertical stretch. In other words, it's going to be skinnier. Okay? If the number out front is like 1/2, 1/3, 3/5, 4/8, 4/9, 7/10, negative 1/2, negative 1/3, negative 5/8, if it's a fraction between 0 and 1 or between 0 and negative 1, that's going to be called a vertical shrink or a horizontal stretch. In other words, it's going to be wider. It's going to be wider. So for this one, what I'm going to do is I'm going to make a table, and it's going to be skinnier than the parent function. Okay? You'll see when we graph it. Okay, so for x values, let's go with, I'll do negative 3, I'll do negative 2, I'll do negative 1, 0, 1, 2, 3. That's good. Let's try to do the easy ones first. When x is 0, what is 3 times the absolute value of 0? The absolute value of 0 is 0 times 3 is 0. When x is 1, the absolute value of 1 is 1 times 3 is 3. When x is 2, the absolute value of 2 is 2 times 3 equals 6. The absolute value of 3 is 3 times 3 equals 9. When x is negative 1, the absolute value of negative 1 is 1 times 3 equals 3. When x is 2, the absolute value of negative 2 is 2 times 3 is 6. When x is negative 3, the absolute value of negative 3 is 3 times 3 is 9. And this is what we're going to graph. So negative 3, 9. Negative 2, 6. Negative 1, 3. You got 0, 0. You got 1, 3. You got 2, 6. And we have 3, 9. Let's graph that. And again, look, it's a vertical stretch. It is skinnier than if it was just f of x equals the absolute value of x. That 3 out front indicates that's what's going to change. Okay. And now let's finish off with example 9. Holy moly, we had 9 examples. Wow, I did not realize this lesson was that long. Okay, here we go. I mean, I knew it was long, but not that long. So I'll try to go quick because I know this video is going a little long right now, but let's make a table. Think back to last class when we graphed the cube root of x. This is going to be the cube root of x. It's going to be shifted down 5, and it's going to be a little wider than normal. Okay? So for the x values, I'm going to pick -8. I'll pick -1. I'll pick 0. I'll pick 1. I'll pick 8. Okay. Let's do the easy one first. The cube root of 0 is 0. Times a half is still 0. Minus 5 gives you -5. Let's do 1. The cube root of 1 is 1, because 1 times 1 times 1 is 1. 1 times a half is a half. And then minus 5 gives you minus 4.5, negative 4.5. Okay. When x is 8, the cube root of 8 is 2, because 2 times 2 times 2 is 8. So 2. 2 times a half is 1. Minus 5 gives you -4. Okay? When x is -1, the cube root of -1 is -1. -1 times a half is -1/2. And a -1/2 minus 5 gives you -5.5, or -5.5. And when x is -8, the cube root of -8 is -2. -2 times a half is -1. Minus 5 gives you -6. So that's what we'll graph. -8, -6. And now let's do the decimals. Just estimate 1, -4.5, -1, -5.5. And then draw your graph. Okay, so that's the end of that lesson. That lesson was called Graphing Transformations of Functions.